So, hello everyone, and welcome to this weekly online session that we conduct on YouTube. And as you all know, that this is an online platform for civil structural engineers to interact with us and ask their doubts or difficulties that they may have related to any RCC steel design concept or any project that they are doing or site and construction issues. So, this is the 40th such episode that we are conducting, and let us begin by taking up the questions. So first question is from engineer Samarth KS. He is from Bengaluru, and he is a working professional. So let's see what he has asked. I'll just share my screen. So he has put up this query, and and I think he had shared one image also. So let me open that image. So he has a tank 120 meter by 90 meter wide, and so for a rectangular water tank, 120 meter into 90 meter with 8 meter height, provided with 30 meter expansion joints, both in the raft foundation and tank walls, with fully open top and peripheral walkway slabs. So I didn't understand, where has the expansion joint been provided. What it what I can see from the question is that this is 120 meter and 90 meter tank, and he's saying 30 by 30 expansion joints. I'm not sure how he's providing expansion joint in tank walls. So if he's live, can he provide more inputs? I'm not sure about this question for provided with 30 meter by 30 meter expansion joints both in the raft foundation and tank walls. How is he providing expansion joints in the water retaining structure? I'm not sure if at all he has to provide. What my suggestion would be to then cast double walls over here. Okay, so that means there will be double walls. If there are double walls that they are providing, then I, in my opinion, these are then independent tanks. Okay, so there is a gap, or there is a discontinuity that has been provided in the raft also, and in the tank wall also. So this means they become independent units. Okay, and if they have become independent units, so these are all independent 30 meter by 30 meter tanks. So even if there is a differential settlement, let's assume, then also I don't think there will be much of a problem, because all these are now independent tank units. So I'm not sure about the question right now. So let him provide more detail. Mr. Samarth KS is informing, as per IS 3370, expansion joints are provided at 30-meter intervals. Oh, is it? But how can you provide an expansion joint in a liquid retaining structure like this? How will you seal it up? How will you maintain water retention? I'm not sure. I don't think in this type of a thing you can provide. If at all you have to provide, then as I told you, there will have to be double walls. That means there will be a tank wall like this, and then there will be a tank wall like this. So there will be double walls over here. So these become independent units in themselves. Only then you can ensure water retention and no water leakages. So I think this, you just review this thing at your own end once, whether really you want to provide expansion joints, because I don't think it can be provided in such structures. And if at all you want to provide expansion joints, then you need to have independent units like this. Now, assuming they are independent units, let's see what he is asking next. Uh, so one question was regarding differential settlement. So differential settlement might not be a problem if your all tanks are filled up, let's say to the same water level, and assuming that the soil is properly compacted. In such cases, differential settlement might not be a problem, because on all raft panels you will have equal liquid pressure. Okay, so that is one. Since both raft and wall have joints, can these cause sliding or horizontal movement? No, why will it cause? There is a water from all sides, so why should it cause any horizontal movement? You are saying due to this soil there might be, let's say due to on this external unit, let's say there was water soil pressure from here and no soil pressure from this side. So you may just check against the friction force, and generally it is seen that the friction forces would be more than this earth pressures. So sliding also may not be a big concern as such. And if we are considering them to be independent units, then the detailing part or reinforcement detailing, you can just do as if they were independent 30 by 30 meter of tanks. So independently you can do them. If the groundwater table is high, can uplift or loss of bearing capacity at the joint location cause any failure in the raft? So now these are independent units. You will have to check them for the uplift also, and ensure that the buoyancy forces are less than the self weight of your structure. So all these things you will have to ensure. But in my opinion, as I repeated, these have to be independent tank units, and as such, you may not be able to provide discontinuities in retaining structures. Okay. All right. So this was his question. Let's move on to next query. Uh, Next question is from engineer Manish Parmar. He is a working professional from Dehradun. And what is his doubt? When column is subjected to axial force plus biaxial moment, then with odd number of pile arrangements, let's say 3 piles or 5 piles, how to calculate net C and T in each pile? Because in case of odd number of piles, they will not be symmetrically placed around the column. So he's saying, let's say this is column and there's a 3 pile arrangement. So let's say this was my pile arrangement. Okay. And this column has some axial load. So you can assume, let's say this column has an axial load of P, and about this axis moment of M, because in case of odd number of piles I will, okay, so P, assuming that you are placing the pile at the centroid of this triangle, okay, so that means this distance will be, let's say, how much, let's say this distance will be x by 3 and this distance will be 2x by 3, where this entire distance from here to here is x. Yeah. So axial load, due to compression, you can assume it to be divided one third, because you have placed the, or rather the pile group CG is matching with the column CG, and for this moment, then you can use that lever arm concept. So you will say that this moment or the forces in the pile due to this moment, let's say there is a tension over here and there is some compression in these two piles. So you can say that T equal to 2C. Okay, this is the vertical equilibrium that you have to maintain. And then you can also say, taking moment about one of the, let's say, if you were to take moments about this, all right, then you could say that T into X minus M into X upon 3 is equal to 0. If I am taking the effect of this about its own will be 0, so I can use this equation. Or if I were to take about this, then also you could do it that way. So using these equations you could find out the T and C. So this is the type of calculation you could do, or obviously you could solve it on some software. These assumptions are valid assuming stiff pile cap arrangement, or assuming stiff pile cap or pile beam, whatever type of system you have provided. If not, then these this these equations may not be valid, but generally we assume stiff pile caps, and therefore this type of calculations you could do. All right. If we, let's say you had a 5 pile cap arrangement, maybe you had placed them in an hexagon, sorry, pentagon. How does a pentagon look like? This, something like this, let's say. Okay, and you had a 5 pile cap arrangement. So let's say you had placed your piles like this, and your column was, or pile CG was matching with the column CG. Now in such a case, again, if you have maintained it at centroid, first of all you need to find out the centroid distance, and then again whatever is the column axial load, that will be equally divided to all these piles. And then for taking moments, you could take about one of the piles and then make that moment equation. Okay, and then solve for it. So in this manner you could, so let's say for example, here now I'm not sure how, where the centroid position will be for a pentagon. I will also need to check the geometry. But let's say these two piles were having some compression. These are equidistant, so I'm giving them same C. Let's say these piles were having tensions, so I'm giving them T1 T1, and I'm giving this T2. So now in this case, we can also use the proportionality equations, and as per their distances, let's say moment is about this axis, about this orange axis. So now in this case, the moment and then these distances, proportionality you could use to arrive at an additional equation. That means I'll say that T2 is proportional to, let's say, some constant k into its distance from this column CG, okay? Or I will say T1 will be proportional to some k into x1, C1 will be proportional to k into, let's say, this distance x3, and then about one of the, let's say, about this axis or about one of the center line of the piles, I can take the moment equation, okay? So T2 into this distance plus 2T1 into this distance plus the moment shall be equal to 0 on this axis. So using that equation I can generate, and then I can replace these values over there to find out the k, and from there I can then find out the pile reactions. So this type of mathematical calculations you can do, or else if you are using some software like safe or stat, you could do it over there also. Understood? When then his second doubt is when column is subjected to axial force plus biaxial moment, then how to calculate net C and T in case of eccentric piles. So eccentric piles, we have covered it in our courses on foundation design. So in eccentric piles, let's say, uh, generally, let's say this is my property line, okay, in plan view, and I have provided a column over here, and then I go for an eccentric pile arrangement, let's say like this, right? So my pile cap arrangement is like this, let's say. This is the plan view. So if this is the case, this is the column having some axial load. Now this distance you know, and this distance you know. So now you can solve using basic mechanics. Let's say this is my support, this is my support. You have a load over here, axial load over here. You know these distances. Now again taking moment about one of the center lines of the piles, you can generate one equation. And over here, let's say if my column axial load is downwards, there will be a tension in this pile, and there will be, let's say, compression in the pile. So you could come up with this equation also, 2C equal to, let's say, P plus, or P is equal to, okay, this C, it's, let's say, downward. So P plus 2C equal to T, something like this you can generate. And then taking moment about one of the center lines, you could generate another equation and then find out the pile reactions. Or again, you can just create a simple model and just see what are the reactions coming in the pile. So these eccentric pile things we have covered in a lot of detail in our course on foundation design and how to come up with these eccentric pile arrangements. Okay, so this was Engineer Manish with his query. Moving on, Mr. Harshal from Nashik, he's a working professional. He's asking, he's asking this query. He's saying while designing the footing, is it okay? It is okay, sorry. While designing footing, it is okay with pressure, but while checking one-way shear, observed shear is more than allowable shear, but the distance d from the face of column goes beyond the footing. So what he is saying is, let's say this is the plan view and this is the footing, and when he is trying to take the d distance is going beyond the footing extent. So this thing does happen. Suppose you have a thick footing, and when you plotted the d distance, it was outside the footing. So what this indicates? This indicates that whatever was the bearing pressure, the thickness of footing is such that the shear will be taken up, or shear will be resisted by due to this positioning of column itself. That means you don't have to worry about the one way shear check in this footing, because the d distance critical section is outside the footing line, outside the footing. That means this column itself will provide enhanced shear strength to this footing, and that's why you can leave the shear check. No need to check for shear in this case, when if the d distance lies outside the footing. Okay. Okay, good. Yeah, this does happen usually when you have thicker footings, and when the footing extent is smaller. This happens. Good. So this was Engineer Harshal. Let's take up the next query. And next query is from Chandrajyoti Sharma, but he has not provided any query. Next query is from Vaibhav Kumar. He is from Nashik. Vaibhav Khairnar. He is from Nashik. He is a postgraduate student. He is saying, after importing grid from CAD, I think he is saying when he is importing grid from CAD in ETABS, it shows a lot of error after overall modeling due to discontinuities of line in ETABS, and it is hectic to draw grid line in ETABS for some complex project. Is there any command for CAD to see discontinuity of lines? No, so whenever you are trying to import directly from AutoCAD, you should be careful, and you have to make proper adjustments and make proper modifications in the AutoCAD itself. Otherwise, there will be problem that you will face later on in ETABS. My suggestion would be, let's say if you have been given architectural drawing with column positionings, you try to draw your own grid lines in AutoCAD. Don't rely on the grid lines that are already there in the drawing. Maybe because they are not properly drawn, or there are let's say discontinuities, or they have used polylines, or they have used line breaks. So don't blindly use the grid lines already there in the AutoCAD drawing. Already there in the AutoCAD drawing. My suggestion would be make your own grid lines. It's not very difficult. Takes a very little time. So make own grid lines in ETABS. Sorry, in AutoCAD. Once you make these grid lines, then shift your drawing to 0, 0, and then use the purge command so that all unnecessary things are gone, and then import this to ETABS using the import architectural grid option. Okay, so that you do. And the more proper work you do in AutoCAD, the less problems you will face in ETABS. Otherwise, if you blindly start importing things from AutoCAD, you will face problem uh, in the ETABS later on. Got it? Yeah. Any book recommendation for connection design for steel structure? I don't know. I mean, you follow any good book on steel structures? Professor N. Subramanian's book on steel structure is very good. You could follow that. Otherwise, any specific book on steel connections, I'm not, I mean, sure about. Others in audience, if they can provide any info, because I'm not sure about any specific good book on connection design specifically. His next query is, what should be the development length for long shear walls? Means if the beam connecting long shear wall of 3 meter, how bars of beam should be embedded in shear wall? 50D. 55 is good enough. So, like you provide the reinforcement inside the column. Similarly, for beams, let's say in plan, this is my beam and this is my shear wall in plan. So, you take it up to 50D. If your beam is merging from this side, and let's say again try to have 50D. If not, many people try to have a shear sorry, a moment release over here at this location, although I don't think it's quite proper. So then try to provide development length by providing L in your bar, L bent in your bar, that you can do. Or if your beam is continuing beyond this also, then you could just provide through bars and development length will be uh, taken care of. All right. Okay. So this was Engineer Vaibhav. And then the next query is from Engineer Dinesh. He is saying, Engineer Dinesh from Tamil Nadu. He is a working professional, and he is saying I designed a PEB structure with jack beam. Jack beam is of RHS this that rests on web of I profile steel column. I designed jack beam as simply supported. What kind of arrangement and how to achieve pin behavior in this connection to withstand wind and seismic loads? So I think what he's saying is in plan view, he has this type of a column, I section column, and let's say this is his jack beam in plan, and now he wants to have a shear connection over here. Okay, let me just make a proper better diagram. So maybe his situation is like this. These are his columns in plan. Okay, and then he had a column like this in plan. In the middle, he didn't have a column, so there was no column position over here. So that's why what he did. So this was his rafter in plan. This was his rafter in plan, and then over here also he provided a rafter, but then this rafter was supported on a jack beam. Yeah. This is the situation he is having. This is his column. So now this connection he is asking, and he has provided a RHS over here, 300 cross 900 he is saying, cross 16. And this is an I section. So basically he is asking about the connection between web of an I section column with RHS, and he wants to have a shear connection. So in this case, you may, if you want to have, now I'm drawing it like this, if you want to have a shear connection over here, I think the easiest way to develop a shear connection will be to go with web cleats over here, cleats. Okay, so in sectional view it will look something like this, and let's say this is my RHS 900. So you will provide web cleats like this, one at the front, one at the back, and you could have holes, through holes, and provide through bolts over here. Okay, so in my opinion this will be the simplest way in which you can provide this type of a shear connection on site uh, to for RHS to uh, web of I section connection. So provide these blue cleats and then get it connected. Yeah. Okay. Is my voice audible to all of you? Yeah, I hope my voice is audible. The next query is from Engineer Venkatesh, and he is asking what are the forces that are critical in designing domes and minarets. So I have never done domes or minarets myself, but in domes, as you all know, the radial stresses and the meridional stresses are important. In case of minarets, I think it will depend more on the geometry, the length, and the diameter, and all those things. So in minarets, I think it will be more about the uh, circumferential normal stresses. That will be more important in case of minarets. In case of domes, I think it shall be more of a radial and meridional stresses. So I don't have any practical experience of doing such things. So you may refer to some, maybe some good books about it, and try to get more info from there. Okay. Yeah. So these were the questions that were provided on the Google form, and we let's look at the email. So there are no queries on the email. Now, if there are any queries in the live audience, we will take them up. So if you have any queries, you may provide it in the comment section. Yes, please. Any queries, questions? Okay. So throughout, so as you all know, once every week we conduct this session. But if you want to provide your queries, you can keep on putting those queries in the same Google form. So this is the link for that Google form. I'm just putting it over here. So this is the link for the Google form. And if you want to contact us on WhatsApp, you can just click on this link to contact us over WhatsApp also. Okay. Yes. So anything else? Okay then. So we have taken up all the queries from the Google form, and there are no more queries, or there are no queries in the live comments also. So then this is all we have for this week. And now we will see you next week with. Okay, Mr. Manish Parmar is asking, the three pile arrangement is not good for biaxial moment case. Yes, you're right. So he has made a good point. He's saying this three pile cap arrangement, let's say I had a column over here. Now this was okay, or this was good for moment about this axis. But if moment was about this blue axis, let's say, this three pile cap arrangement may not be very good. Okay. Although you have these two piles to take the loads, but then there will be a certain eccentricity that gets introduced. So three pile cap arrangement may not be very good in that case. But then the way out is that you tie it up with ground beams. So what people do is, or what your code also says, let's say this is your three pile cap you had. So about this axis you provide the ground beams or tie beams, plinth level. So then these green beams will help you to take moment about this axis, the magenta line that I've drawn. So about the magenta line, the green tie beams will help you, and about the black line, you have the piles to take care. So then you will have to integrate it with tie beams like this. Otherwise, as you correctly pointed it out, three pile cap arrangement may not be very good to take the moment about the pink axis. Okay, good. Okay, so that's it then. Thank you. We'll see you next week now. And during the week, as I just said, you can keep providing your queries and questions in the Google form. And if you want to contact us on WhatsApp, This is the link. All right. See you next week then. Bye bye.